Hello, everyone. My name is Eli Walton, and today I'm going to be talking about Lab 5, the virtual lab that we're doing. So basically, I'm going to be describing, as you can see on the screen, I'm going to be describing, breaking down the lab report that I did, breaking down the solution of Fe3 plus SCN negative, then the arrows Fe parentheses SCN 2 plus. So I'm just gonna break it down by the grading sheet and the rubric, and this is how I did my little lab report. So for colors, if we want to break this down even more, for F3 or Fe3 plus starts off as a pale color, then the SCN negative is actually colorless. And then when you bound these solutions together in the color mixture, it creates a deep bloodish red color. And then when we start to add heat to it, the deepest bloodish red color actually starts to lighten. It starts to fade because a lighter color starts to fade. And the equilibrium starts to shift to the left than in the solution, and then it produces more of the Fe 3 plus than the SCN negative. And then when the heat starts to act more as a product, it increases the temperature and shifts the equilibrium to the left, leaving it as an exothermic. When adding reactants, the equilibrium shifts to the right, and more of the FeSCN 2 plus forms, which makes the deep bloodish color of red come back. And then when you start to add like the AgNO3 solution, it creates more of a silver nitrate or a whitish color, and it reacts when it attacks the thiocyanate ions. And removing SCN negative causes the equilibrium shift back to the left, which makes the color red fade since the Fe SCN2 plus breaks down and removes the SCN negative. So I hope that was broken down good enough. And so then when the overall use of that Lee Chatelier principles, basically this principle states when a system at the equilibrium is like distributed by like a change of temperature, pressure, or even a concentration, the equilibrium will shift to any direction that reduces the most disturbance or the least of disturbance. So like I was saying, like for this reaction, adding Fe3 plus or SCN negative shifts the equilibrium to the right, producing more of a bloodish red color. As when you mix the solutions for FeSCN 2 plus, removing SCN negative, like with AgNO, shifts the equilibrium to the left, decreasing the red color, making it more faded, and because it's more AgNO3 is more like a whitish color. Like I said before, like the thiocyanate ions, like it's a whitish color, so it's making it more lighter and more faded away and more distant from the actual deep bloodish red color. And then adding heat shifts the equilibrium to the left as well, because the forward reaction is more of exothermic. So when that absorbs into the system, the added heat is being favored as the reaction that's being more of reversed. So these are more of the standard observations, and this is the overall reaction that I got using this type of principle. So I hope you enjoyed. Let me know if there's any questions if you're grading my paper, if I need more information, or my lab report if I need more information. I need more depth in my observation. Hope you enjoyed my video and my lab report. Thank you for listening.